Good morning, students. Myself, Sri Krishnandra Sahu, Department of Electrical Engineering, Bose, Kotak, Odisha. So today we discuss about the signal flow graph and the properties. Because in the previous classes we have discussed regarding the block diagram, and from the block diagram how you find the transfer function by using block diagram reduction method. Actually what happens, block diagram reduction method, last class I have told you, you have seen when I was solving the numericals, the problems. Block diagram reduction method is a lengthy method. It is a very lengthy method because each step you have to draw the figures or block diagrams. So it is a complex lengthy method. Because we सब देखिए previous method रे block diagram reduction method रे जो आम transfer function बाहर करते overall transfer function आम बहुत गुड step करते step 1 step 2 step 3 सब step रे आम figure draw करते lengthy method, okay, or complex method. So this problem is eradicated by a new method, signal flow graph method. Signal flow graph method ta a simple method finding the transfer function of a system. So signal flow graph method रे आमे also transfer function बाहर करी परिबा, overall transfer function by equivalent transfer function. It is simple method. Okay. So in my topic I give you the outlines that you see. So in this topic I discuss about introduction of a signal flow graph, definition of a signal flow graph, important terms regarding signal flow graph, and so construction of signal flow graph for a linear equations. A setup for a particular system, some linear equations are given. What equation they throw? What equation? Within the equation, linear equation, plane equation, x, y. In that equation use re करके आमे signal flow graph draw करिबा. Means linear equation पे आमे signal flow graph draw करिबा. एवं signal flow graph रू आमे बाहर करिबा transfer function. You see here. So first discuss about the introduction. So I have told you already. It is simple method. Signal flow graph पे लमाने गोटे बहुत सहज method, simple method. Comparison to block diagram method. Block diagram reduction method रे जामे transfer function बाहर करते complex, complicated method, lengthy method. So but signal flow graph is an easy method to find the overall transfer function of a system. Secondly, this signal flow graph is developed by S.J. Mason. The scientist S.J. Mason is derived this process. This S.J. Mason, the scientist here you see, S.J. Mason, he derived this one, scientist S.J. Mason, who derived the signal flow graph, SFG. It is shortly called signal flow graph, also called as SFG, signal flow graph. And it is applicable for linear system. It is applicable only for linear systems, you see. Okay. So what is the next you see? Definition of signal flow graph. Signal flow graph is nothing but, you see, signal flow graph. So it is consisting of some, you see, it is consisting of some nodes are here. And it is for also applicable for some represent as simultaneous linear equations. If you have linear equation, simultaneous equations, back-to-back equations are there. And for the linear or simultaneous equations, the signal flow graph is the representation method. Signal flow graph contains some nodes and some branches also here. So each branch is also directed. Signal flow graph signal flow graph you see like this one. Yes, signal flow graph. This one is a signal flow graph here. Okay. A signal is here. So this is a node 1, x node, x1. This is node x2. So this is the signal, arrow mark here. Arrow mark indicates the flow of signals, and near the arrow mark for each branch, the part between two nodes, theta node bhitar jo prast am takaya branch. This is a branch here, branch is here. Branch पर arrow mark दिया है तब पकड़ transmittance लिखा है that A1 return A1. A1 is transmittance. What is A1? X1, X2 are node. A1 is transmittance. Transmittance or transfer function, transmittance or transfer function. So means the transmittance or transfer function of a branch is written near the arrow mark. Arrow mark or pakha pakhi ta upare ame lekhiba transmittance value by transfer function value. Jemti lekhuthile block diagram re kon lekhuthile gote branch re gote block thae, block bhitar lekhuthile transfer function value. Kintu ethi ame kon kariba na gote branch रे तापर एरो मार्क दबा. एरो मार्क इंडिकेट्स फ्लो ऑफ सिग्नल्स. एरो मार्क पाखो लिखबा जो वैल्यू A1 दैट इज ट्रांसफर फंक्शन और ट्रांसमिटेंस वैल्यू. जस्ट एरो मार्क पाखो लिखा जाए ट्रांसफर फंक्शन वैल्यू और ट्रांसमिटेंस वैल्यू. ओके. So every branch of a signal flow graph having an arrow mark. You see here is arrow mark. This indicates the flow of signals. प्रत्येक ब्रांच एरो मार्क थिबो एवं that arrow mark indicates the flow of signals. Okay, these are the basic idea of the signal flow graph. Signal flow graph consisting of some nodes and some branches. Branches are arrow mark. Arrow mark indicates the flow of signals. So we'll go to the some terms related to signal flow graph. There are some important terms which is related to signal flow graph. You see here. So this is signal flow graph is here. I just take example here. A signal flow graph. So here you see x1, x2, x3, x4, x5, 6 nodes are here. You see what is the number of our nodes here? 6 nodes. x1, x2, x3, x4, x5, x6 are 6 nodes are here. Okay. So what are the nodes here? How many nodes are here? You see. Nodes are here. x1 is a node. x2 is a node. So node how much here? What are the nodes here? Nodes are x1, x2, x3, x4, x5, x6. 6 nodes are here. Okay. So see, arrow mark is given here for x1 to x2 branch, transmittance A12, x2 to x3 transmittance is forward rail A23, backward rail A32. Similarly, x3 to x4, A34 is the transmittance. Then x4 to x5 transmittance is A44. This is a loop you see, a self loop. Transmittance is A44. Similarly, x5 to x6 transmittance is A56. Okay. So near each you see each branch which connecting the two nodes given by arrow mark. Arrow mark indicates flow of signals, and near every arrow mark there is transmittance value is given. A transmittance or transfer function A12, A23, A34, A45, A44, A56, A32, A43, A35. These are transmittance or transfer function value of that branch. Okay. So what are the terms discussed here? I have told there are so many terms are here linked to the signal flow graph. This is a picture of a signal flow graph. It is a SFG picture. It is signal flow graph. SFG. This is figure of a SFG for a particular equations. So see, so what are the terms? Number 1 is input node or source node. Number 2 is output node or sink node. Number 3 is mixed node. Number 4 transmittance or transfer function value. Number 5 is forward path. You see, these 5 points are here. There are also another 5 points in the next slide. So you see there are 5 points discussed for input node or source node. You see input node. Input node means starting node. Input node you see x1 is input node. Here the input node is x1. Input node or source node x1, because so this is a node which has only outgoing branches, which has only one outgoing branches. Though node ro gotti outgoing branch bahar hai, outgoing branch, the node which has only outgoing branches. Okay, you see x1 le gotte branch bahar chi outgoing na incoming, outgoing. So here x1 node is a input node. This x1 is a input node because it has only outgoing branches. That is x1 to x2. Then the input node is also a source node because signal start here. Signal is start this point, source node. Then output node or a sink node. You see, output node means the last node. Last node you see x6. That is x6. What is the output definition? Output node or sink node. It is the node which has only incoming branches. देखो x6 खाली incoming होची ना नहीं, x6 की सब signal entry करची. So this output node has only incoming branches. Only incoming, only outgoing है input node, outgoing branch. Okay. Then output node only incoming branches. Incoming branches. खाली incoming थी वो जो node रे only incoming. That is output node or sink node. Sink. Signal is sink here. Signal is end here. Okay. Then you see mixed node. What is a mixed node? You see mixed node or you see here x2 because the node which has incoming branches, outgoing both. The node which contains incoming and outgoing branches is called a mixed node. देखो x2 रे incoming अच्छी, outgoing अच्छी. Then x3 रे अच्छी incoming, outgoing. x4 भी अच्छी x5 रे अच्छी ताले x2 x3 x4 x5 are known as okay you see x2 x3 x4 x5 एमान कहते मिक्स नोड पिला माने these are mix node काहे कि तांकर इनकमिंग ब्रांच अछि आउटगोइंग ब्रांच अछि देखो x2 रे इनकमिंग अछि लेफ्ट साइड रे इनकमिंग राइट साइड रे आउटगोइंग the node which has incoming branches outgoing branches both that is called mixed node ठीक अछि रेडी केतरा मिक्स नोड x2 x3 x4 x5 चारटा मिक्स नोड ओके देन वी डिस्कस transmittance means transfer function so it is the transmittance or transfer function written near the arrow mark पर जो वैल्यू लिखा है a12 a23 transmittance a12 a23 etc okay this value near the arrow mark जो वैल्यू लिखा है a32 a44 these are transmittance or transfer function which written near the arrow marks okay then forward path students you see what is forward path it is a very important part there in signal flow graph these are terms relating to signal flow graph forward path means you see it is a path which start from the input node के x1 output node के x6 input node रे बाहर थिबो output node रे से सरुथबो start from the input node end with the output node x1 रे बाहर तो x6 रे सरुथबो along which no node is traversed more than one माने गोटे के नोड एक रो अधिक थन नथिबो गोटे नोड को तमे थरे टच करिवो गोटे नोड को सिंगल टाइम टच करिवो गोटे नोड को बाहरिबो स्टार्टिंग नोड रे सरिबो कोडी एंडिंग नोड रे जो पाथ रा पाइबो दैट इज कॉल्ड फॉरवर्ड पाथ हला गोटे पाथ स्टार्ट फ्रॉम द इनपुट नोड रे बाहरिबो पिला माने इट स्टार्ट फ्रॉम द इनपुट नोड एंड एंड विथ द आउटपुट नोड इनपुट नोड रे बाहरिबो आउटपुट रे एंड हबो बट नो नोड इज कमिंग मोर देन वंस केबे कोन से नोड को डबल टाइम नबने सिंगल टाइम तने बर्तन पाथ कोन पिला माने x1 x2 x3 x4 x5 x6 तबे एठी फेरी परिबनी a35 देख जाई परिबनी काना ओके सो व्हाट इज द फॉरवर्ड पाथ हियर केतरा फॉरवर्ड पाथ ही परिबो तंग हो यू सी हाउ मेनी फॉरवर्ड पाथ हियर x1 बाहरिबो फॉरवर्ड पाथ हियर x1 देन x2 देन x3 x4 x5 x6 ये गोटे फॉरवर्ड पाथ दिस इज फॉरवर्ड पाथ सेकंड फॉरवर्ड पाथ x1 बाहरला x2 देन x3 देन पूरा तळ बाटे पळेसला को बाटे a35 देख x5 माइन देन x6 x1 x2 x3 x5 x6 okay so this is a forward path one forward path this is another forward path this is another forward path so two forward path here okay so there are two forward path means start karibo input node re end karibo output node re ता मझे रे गोटे की नोड जेमिति डबल टाइम्स आसीबनी सिंगल टाइम्स आसीबो सिंगल टाइम तुम क्रॉस कर जिवो गोटे नोड को ए नोड नेवर कम्स मोर देन वंस गोटे नोड को थरे छुइबो इनपुट रे बाहरिबो आउटपुट रे पहुंचबो जो पाथ रे पाइबो दैट इज कॉल्ड फॉरवर्ड पाथ okay so here two forward path what is the number of forward path here are two forward paths here इतना लिखा है दिटा 1 2 two forward path here in this picture in this signal flow graph two forward paths is there okay these are the terms are here forward path we discuss about forward path now you discuss about you see next one you see okay loop okay if I draw the picture here you see I the picture draw here how many here 6 x1 x2 x3 x4 x5 x6 hela okay students I draw the picture again here okay so x1 to kon kaiba 1 2 2 3 transmittance 3 4 4 5 5 6 गोटे सेल्फ लूप करथिला Fourth self loop, that is a 4 4. A self loop there. Okay. Then out self loop korthila pila mane, you see here. A self loop is here. You see here loop. You just look the loop here. So at a loop. Loop means it is a path that start at the same node and end at the same node. You just look here. I am discussing loop. Next time I am discussing loop here. You see. Next time loop in the next slide. I discuss a loop here. Loop means number 6. What is the loop here? Loop means you see. This is loop. Loop. Start from the x2 node and x2 node. So it is a path which start and ends same node. यदि आमे गोटे सेम नोड रो बाहरिबा स्टार्ट करिया पुणी से सेम नोड रो पहुंचबा बुझ परछो सेम नोड रो बाहरिया पुणी सेम नोड रो आस्की एंड करिबा द पाथ इज कॉल्ड लूप एवं मन लख से पाथ रे जेमते गोटे के नोड डबल टाइम्स आसीबनी दैट मींस ए लूप इज ए पाथ इट स्टार्ट्स एट द एंड्स एट द सेम नोड along which no node comes more than once थरे मात्र कोन से नोड दिथर आसीबनी x2 बाहरला पुणी x2 पहुंचबो. This closed path is a loop here. Okay? Our loop कौन सी पिलाने देखो? This is also loop here. x3, x4, x2. So what is the loop here? Loop प्रथम loop वाला हमारा कौन हमारा x2, x3, x2 टे loop देखले. पूर्ण loop होची x3, x4, x3 loop होची. Loop forward path. This is loop here. x3, x4, x3, x4, x3 loop here. Okay. पुन देखो x3, x4, x5 ना ये loop नहीं. This is not a loop. So how many loop here? Two loop here. You see here two loop is here. x2, x3, x2, x3, x4, x3. Two loops are here. So तुम भावो कि x3, x4, x5, x3 बना है. इटा उटे forward अच्छी. So वो उटे closed loop होता है. Loop is a closed loop. Loop must be closed. It's not closed. जो लूप रे बाहरिबो जो नोड रे बाहरिबो से नोड रे टर्मिनेट हबो कोन से नोड जेमति डबल टाइम्स आसीबनी दैट इज लूप हियर. ओके देन सेल्फ लूप द नंबर 0.7 इज सेल्फ लूप. यू सी सेल्फ लूप पिला माने सेल्फ लूप माने जो नोड रे बाहरिबो से नोड टर्मिनेट हबो. इट स्टार्ट्स एंड एंड्स सेम नोड. इट स्टार्ट्स एंड एंड्स सेम नोड. से आ कोन से नोड को छुईबनी जो नोड रे बाहरिबो से नोड टच करिवो. देखो व्हिच वन x4 4 x4 x4 only x4 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 बाहरला you see here x4 बाहर की पुणी को टच है x4 है. it is self loop. This is self loop. This one is self loop x operator. Okay man self loop means it is a path that starts and ends same node. जो path रा same node start हबो same node end हबो that is self loop. There is only one self loop. This is self loop. This one is a self loop here. Okay, x4 x4 ता नाम x4 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 बाहरला पुणी x4 एंड हला self loop. Then students will discuss about path gain. What is a path gain? Path gain means okay गोटे path रे मोटे path हमें कौन पाइथिले पूर्वरु for the forward path रे कौन पाइथिले x1 x2 x3 x4 x5 x6 गोटे path रे जति gain थिबो सब gain को मल्टीप्लाई कर दा path gain पाइ जिबा. What is path gain? It's the product of all the gains present in a path. गोटे path रे आमे जति gain थिबो मन कर गोटे path हला x1 x2 x3 x4 x5 x6 forward path तार gain गबो तार path gain गबो. What is path gain? Path gain माने तार सब gain मिसे गुणी दबो multiply on gain a1 2 a2 3 a3 4 a4 5 a 5 6 सब gain को all gain multiply all gain you multiply all gain in a path. गोटे path gain माने गोटे path रे जति gain थिबो this gain this gain this gain this gain this gain so multiply कर all multiply or gain you multiply that path gain. Okay loop gain means then is a loop gain. 80 grammar what is the 8 terms 8 is path gain we are discussing here. Path gain gala 8 point. The 9 is loop gain. What is loop gain? Loop gain. Okay. Loop gain means the gain product of all the gain in loop. गोटे loop रो जति gain अछि से multiply कर दो. देखो एटा loop थिला. ये loop is here. This loop is here. Okay. So what is the loop gain here? This loop रो gain केते पिला माने? Here. This loop has gain. You see. This loop has gain how much? this loop is loop ना कौन x2 x3 x2 ता गेन कौन हबो ना a23 a3 टू मल्टीप्लाई कर दो से लूप रे जति गेन थे मल्टीप्लाई कर दो सो लूप गेन केता हबो लूप गेन हबो a23 into a32 मल्टीप्लाई कर दो दीटा पुणी गेन लूप रे जहां गेन थिबो a23 a32 मल्टीप्लाई कर दो सो लूप गेन मींस व्हाट द लूप गेन means it is the gain of the loop. Okay. Next, number 10 point is very important point. Non-touching loops. Non-touching loop. Number 10 is very important. Non-touching loop. You see, you just look here in this signal flow graph. You just look. Which loops are not touching? को loop तुम touch कर नहीं. Which loops are not touching? Now, non-touching loop are having no common nodes, no common path, no common branch. माने दीटा node के touch कर नथिबो, दीटा loop के touch कर नथिबो. You see, this loop is non-touching. तमाने x2, x3, x2 loop, आउ x4 loop, x4 ये जो लूप वाला दिस टू लूप आर नॉन टचिंग देखो ए लूप टच कर चुकी टच करना जो दिरा लूप टच न करथिबे से मान कोंती टू नॉन टचिंग लूप मान कर डाला L1 एटा L2 त माने L1 L2 नॉन टचिंग L1 एंड L2 नॉन टचिंग L1 एंड L2 वाला नॉन टचिंग लूप्स ओके नॉन टचिंग लूप्स ए दिना लूप भीतर देखो पिला माने ए लूप नॉन टचिंग ता भीतर किछि कॉमन नोड अछि कि नोड किछि कॉमन अछि कि ना नोड किछि होई नै ब्रांच किछि कॉमन नै ब्रांच अछि कि नै लूप किछि कॉमन अछि लूप नै पाथ किछि कॉमन अछि पाथ किछि कॉमन नै ओके सो नोड ब्रांच पाथ किछि कॉमन नथिबो जहा द्वारा कि नॉन टचिंग से माने परस्पर कि टच करन कोठु टच करन नथिबे नॉन टचिंग लूप्स सो दिस इज नॉन टचिंग लूप्स सिमिलरली आल्सो नॉन टचिंग लूप्स यू कैन सी बट यू सी दिस लूप दिस टचिंग ए लूपटा टचिंग okay then middle loop one this loop touching non touching so important part is non touching loops are here so discuss about non touching loops you just see the definitions are here the remaining part definition you just see okay loop means it is a path that starts and ends at the same node along which no node is traversed more than one loop माने गोटे जो नोड रो आरंभ होतबो से नोड रो सरुथबो गोटे के नोड डबल टाइम आसुनथबो सेल्फ लूप कोन it is a path starts and at the same node जो लूप रे बाहरिबो से लूप रे एंड करथबो जो पाथ रा ता कोन सेल्फ लूप पाथ गेन कोन गोटे पाथ रो जति गेन थिबो गोटे पाथ रे इन पाथ ऑल गेन प्रोडक्ट करिवो लूप गेन केन गोटे लूप रे जति गेन थिबो a1 2 एंड लूप रे सो गेन को मल्टीप्लाई करे लूप गेन पाइबो नॉन टचिंग लूप कोन दिस लूप्स हैव नो कॉमन नोड्स नो कॉमन ब्रांचेस नो कॉमन पाथ्स जो दिरा नोड भितर किछि टच न करथिबो किछि कॉमन नथिबो से मान कोन नॉन टचिंग लूप्स दिस आर द 10 इंपोर्टेंट टर्म्स linking with a signal flow graph. These are the very important points here. Okay. So thank you very much. We completed the signal flow graph, basic idea of a signal flow graph, introduction, and also definition of signal flow graph and different terms linking with the signal flow graph. So next class we will meet each other and discuss about the construction of a signal flow graph from a linear equation. If you set up a linear equation given equation deythibo linear equation we draw the signal flow graph. How you draw the signal flow graph we will discuss in the next class. Thank you very much.